Hello and welcome. This is going to be session for IGCSE 8th grade students, and the subject this time is mathematics. And the very first topic that I'm going to start with is something called rational, irrational numbers and the indices. Okay. So whatever theory, whatever concepts are there, first I'm going to discuss that, and then we will be doing some exercise from the textbook. So let us get started. So till now, in the 7th grade, and when you completed your 7th grade, you must have by that time be familiar with something called integers, right? So you know what are integers, you know what are fractions, okay? And now you should know what is rational numbers, what are irrational numbers, and what are indices. So you have to start with this for the 8th grade mathematics. So let us start with the meaning and the definition of the rational numbers. Okay. So here we go. Okay. So first we are going to start with the meaning and the definition of rational numbers. So the definition of rational numbers, see, definitions are many for rational numbers, but the main thing is you should understand what are rational numbers. Okay. So there is not only one approach and one definition to understand rational numbers. There are many ways in which you can conclude whether a number is a rational number or whether it is an irrational number. Okay. So the definition of rational number is precisely this one. It starts from here. This is the definition, right? If P and Q are integers such that Q is not equal to 0, then all numbers of the type P divided by Q, that is a fraction of P and Q, P divided by Q are said to be rational numbers. And P can be 0. Okay, P can be 0, but Q should not be equal to 0. So basically, there's an alternate way of putting this definition. Any fraction of the type P upon Q such that in the numerator you have P and in the denominator you have Q. Both can be integers. Only restriction is the denominator. In the denominator, the integer should not be equal to 0. Okay. Now this I am telling you because in mathematics, anything divided by 0, okay, any number divided by 0, it's irrelevant when whatever you have in the numerator. You may have a positive number, you may have a negative number, but that is not important. But if you divide by 0, if there's a 0 in the denominator, such a number, okay, is something which is known as meaningless, okay, or it is not defined. So any number x divided by 0 will be treated as a meaningless number, okay, or not defined. It is not defined only in mathematics. And that is why any number of the form P by Q, where P and Q are integers, but then Q should not be equal to 0, right? And if Q is equal to 0, then it will not be a rational number, right? It will not be any number. It will be meaningless. So if P and Q are integers such that Q is not equal to 0, then all numbers of the type P divided by Q are said to be rational numbers, and P can be 0. Okay, so suppose, now let me first make you this concept very, very clear. 0 divided by any integer, now integer I will write I for integer, okay. 0 divided by any integer will always give you 0 as the answer, okay. And second thing is, any integer divided by 0 will always give you the answer as something called meaningless, or you can say not defined. Okay. So these two things you should remember very well if you want to start understanding mathematics nicely, and if you want to build up your concept, first become very clear of these two statements. Okay. So whenever there is 0 in the numerator of a fraction, okay, irrespective of what is there in the denominator, the answer will be 0. And if there is a 0 in the denominator, irrespective of whatever you have in the numerator, the answer for that fraction or the value of that fraction will be something which is called as meaningless, or it is called as not defined. Okay. So let us take some example. Let us take 2 upon 5. Now 2 upon 5 is of the form p upon q. P upon q, both are integers. 2 is also integer, 5 is also integers. Okay. And moreover, your denominator, that is q, is not equal to 0. It is 5. So it is not equal to 0. So this definition fits. This ratio p upon 5, p upon 2 upon 5 will be a rational number. Okay. Because the numerator 2 is an integer, denominator 5 is also an integer, and it is a non-zero integer. So this fraction 2 upon 5 is going to be a rational number. So it is a rational number by definition. Let us take this 50 upon 3. 50 upon 3 also, 50 is an integer which is in the numerator, 3 is in the denominator, and that is also integer. So both are integers. Moreover, this denominator is not 0. It is a non-zero integer. So by definition, 50 upon 3 is a rational number. So this is a rational number. This is also a rational number. Now minus 15 upon 2. Minus 15 is an integer in the numerator. 2 is a integer in the denominator. So both in the numerator and denominator you have integers. And moreover, your integer in the denominator is a non-zero integer. So minus 15 upon 2 is also a rational number. So by the definition of this rational number, this is the simplest way of deciding whether a number is rational or not. 7 upon minus 2, 7 is an integer, minus 2 is also an integer, and minus 2 is a non-zero integer in the denominator. So 7 upon minus 2 is a rational number. Now 0 upon 5, now 0 upon 5, as I told you, 0 divided by any integer, I've written here 0 upon any integer is ultimately equal to 0. So 0 upon 5 will be equal to 0. 0 upon minus 2 will also work out to 0. And 0 is an integer. Okay. So all integers are even otherwise rational numbers. So 0 upon 5, 0 upon minus 2, by definition, because the denominator are non-zero, p can be 0. The numerator can be 0. Okay. So here the numerator is 0 in both this case, but denominator is not 0. So this fraction will be a rational number. So this is also a rational number, right? So this is one way of deciding whether a number is a rational number or not. Second thing is, all integers are rational numbers. See, I have written here, all integers. See, okay, we'll come to that later. So this fraction, you know, wherein the denominator is a non-zero integer, are always rational numbers, right? You will see that all these numbers will reduce. Now suppose these fractions, you know, 2 upon 5, 50 upon 3, minus 15 upon 2, all these are rational numbers, but still, you know, you can approach in a different way. Suppose 2 upon 5, which is in the fractional form, if you convert it into decimal form, then 2 upon 5 will give you the answer in decimal as 0.4. Now 0.4 is known as a terminating decimal. 0.4 is known as a terminating decimal. Okay, because after 0.4, the division stops. You get a 0 in the remainder. Okay, so that is known as a terminating fraction. So 2 upon 5 is a terminating fraction, and the answer to that is 0.4. So this is known as a terminating decimal. So terminating decimal is also considered as a rational number. Then 50 upon 3, if you try to work out, the answer will be 16.666. This is known as recurring decimal. This is terminating decimal. Okay, terminating decimal. This is known as recurring decimal, because after the decimal, you will see certain digits getting repeated. Either a single digit will get repeated or a group of digit will get repeated. Okay. In either case, it is known as recurring decimal. So here, your 6 is getting repeated every time. 16.66666 you are getting as the answer. So this is known as a recurring decimal. So terminating decimal and recurring decimal are also coming under the category of rational number. So 50 upon 3 is a rational number by this definition. P upon Q is a P and Q are integers, Q not equal to 0 by that definition. And 50 upon 3, if you work out in the decimal form, it will give you the answer as a recurring decimal. So recurring decimals are also rational numbers. Okay. Then minus 15 upon 2, if you try to convert in the decimal form, you will get the answer as minus 7.5. And minus 7.5 is a negative terminating decimal. 7.5 is a terminating decimal and it is minus sign. So minus terminating decimal. So whether it is positive or negative, if it is terminating decimal, then it is recurring. So minus 7.5 is also recurring decimal and therefore it is a rational number. And again 7 upon minus 2 is minus 3.5 and minus 3.5 is also terminating decimal or terminating fraction. Okay. So whether you call it terminating fraction or you call it terminating decimal, one and the same thing. Okay. So all these, are rational numbers. But here we are telling them as rational number because they are either terminating or they are recurring. Okay. So if a fraction is terminating or if a fraction is recurring, then it is known as a rational number. It is a rational number. Okay. So this is the second approach. Now, all these are either terminating fraction or recurring fraction or zero. In certain case, you got zero also. See this 0.5, you got the answer as 0. And 0 is an integer. So all integers are also coming under the category of rational number. Right? This means that all integers, okay, even minus 5, it is an integer. But minus 5 can be written as minus 5 upon 1. Now, once you write this minus 5 upon 1, and if you try to go by this definition, then minus 5 in the numerator is integer, 1 in the denominator is also integer, and 1 is non-zero integer. So it's a fraction which is nothing but rational. Okay, because by this definition, P upon Q will be a rational number. So minus 5 can be written as minus 5 upon 1, and that is the way we can say that any integer is a rational number. And same way, if you have, say, 25, okay, just 25, then 25 can be treated as 25 upon 1. So again, 25 upon 1 is also a rational number by definition. And even otherwise, 25 upon 1 is equal to 25, which is a terminating number. Okay, so it is a rational number. So this is the way, by different approach, you can decide whether a number is rational number or not. Okay. Now let us take few more example. Okay, 100 upon 3. Now 100 upon 3, it is a rational number because 100 is an integer, 3 is an integer. So this fraction of 100 upon 3 is always a rational number. 22 upon 7 is also a rational number. 22 is an integer, 7 is an integer. So 22 upon 7 will be a rational number. Okay. Now here 22 upon 7, that is the value of pi that we use in our mathematics to find the area of the circle, pi r square and all that, we take the value of pi as 22 upon 7. And you must be using the pi value as 3.142 also. Okay, or 3.14. Okay. So here many students, of your age, they have a little bit of confusion, right? So let me first clear that confusion. Now in the school, okay, in your 7th grade, in your 6th grade, you must have used pi value as 22 upon 7. And sometimes they ask you to take pi value as 3.14. And when you take pi value as 22 upon 7 and somebody asks you whether it is a rational number or irrational number, so your answer should be 22 upon 7 is a rational number. Why? Because 22 is an integer, 7 is also an integer. Moreover, the integer in the denominator is a non-zero integer, it is not 0. So by definition, this 22 upon 7 fraction is a rational number. Fine. Now, if you try to do the division and try to find out the answer to this 22 upon 7 in the decimal form, then what happens when you start dividing, you get an answer which is recurring. See, in fact, this 22 upon 7, if you try to divide, you will get the answer as this 3.143857, and then after 7 again 142857 will be repeated. So this particular part after the decimal point 142857, okay, this much part is recurring. If you carry on the decimal after 7, again you will get 1 142857. Again you will get 142857. Now again you will get 142857. So this part 142857, this bunch of number is going to recur every time when you carry on the division. So you will never get a 0, but it will be a recurring decimal. And I have told you that recurring decimals or recurring fractions are also rational number. So by that way, 22 upon 7 is a rational number. Now 3.142 or 3.14 is something which looks like a terminating decimal. Anybody will think that remainder has come 0 and the answer is 3.114. Now this value is just an approximate value that the teachers tell us to take instead of 22 upon 7. Okay, so it's an approximate value that you are taking. So it is not a terminating actually fraction. Okay, 3.142 is not a terminating this thing. It's a recurring actually. Okay, it's a non-terminating and it is recurring. You will never get answer remainder as 0. It will go on. Okay, so by definition, pi value, which is 22 upon 7, is a rational number. Okay, fine. Okay, now actually speaking, this pi value 22 upon 7 is a rational number. When you take 22 upon 7, it will be rational number. But actually speaking, pi value is not 22 upon 7. This we take as 22 upon 7. But pi value, pi is an irrational number. Okay, pi value is actually 3.142 and then it goes on. Actually, it is not even recurring. Okay, it is not recurring. It will not be recurring also. It will go on. It is 3.142857. We take it for consideration. Okay, so pi value when it is 3.142 and this dash dash dash, this is not dash dash dash, this is dot 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 dot. Okay, so when it goes on continuing, this is known as non-terminating, non-recurring. Okay, so any number which is non-terminating and non-recurring, such numbers are known as irrational number. Okay, so when you take pi actual value, it is an irrational number. But for the convenience sake, when you take pi as 22 upon 7, then that time it is a rational number because it is in the fractional form. Okay, are you getting me? And 22 upon 7 is a rational number because when you try to divide 22 upon 7, you will get a recurring number. And recurring number is also rational. So this logic you should always have the clarity. Okay, very much it should be very clear in your mind. I have seen many students getting confused because teachers, you know, they tell many a times that take pi as 22 upon 7 or you take pi as 3.14 and when you go to higher class, the pi value is actually 3.142 dot 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 dot. Okay, so you don't know actually what is the value of pi. Okay, and of course the value you know, but you don't know whether it is rational or irrational. So when you are taking or when you are treating pi as 22 upon 7, definitely it is rational number. When you are treating pi as 3.142 dot 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 dot, this dot 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 means it is the number, this after the decimal everything is not coming to an end, means this division is never going to end. You will never get remainder as 0, so it is non-terminating. Moreover, you will never get some recurring part also after the decimal, so it is not even recurring. So if it is not if it was recurring, then definitely it is a rational number, but it is not recurring also. So actually pi value is an irrational number, but when you take it as 22 upon 7 or when you take as 3.142 approximate value, it is treated as a rational number. Okay, so this I wanted to make it very clear. Now 22 upon 7 is a rational number because when you reduce it, you will get this 100 upon 3 will be 33.33. This is recurring. And 22 upon 7, when you reduce it, you will get 1.3.142857. And after that, you will get again 1.42857. So it is recurring. So these are taken as rational number. Okay, but pi is equal to 3.142 dot 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 is an irrational number. Okay, as it is a non-terminating and non-recurring. So irrational numbers are numbers which are non-terminating and non-recurring. So it is not a rational number, but it is an irrational number. Okay. Now This is all about rational numbers. Now let us go to the next slide, and here it is saying uh, definition of irrational number. So now let us try to write down the definition of irrational number. Before you write the definition of irrational number, one simple definition is this one. Numbers which are not rational are irrational. Okay, so numbers which are not rational are irrational. So rational numbers, you know the various approaches of deciding whether a number is rational or not. Okay, by some way, if you come to know that a number is not rational number, then that number is an irrational number. Okay, so all numbers which are not rational are irrational. That is the best definition of irrational number. But then again, there are other two definitions also. Let us go for this one. All non-terminating and non-recurring fractions are irrational. Now see, non-terminating and recurring fractions are nothing but rational numbers. Okay, so non-terminating and non-recurring fractions will be irrational number. I told you the numbers which are not rational will be irrational. So a number which is non-terminating and non-recurring will not be a rational number, and because it is not a rational number, it will be irrational number, right? Now another definition of rational number is, or another approach is, this is a square root sign. This is known as, in general, this is known as a radical sign. Okay, this is also a radical sign. Suppose you have a 3 over here, or if you have a 4 over here, these all are known as radical sign. Okay, now this radical sign with some number over here, and this number, if it is a non-perfect square, if it is a non-perfect square, here in this case it should be non-perfect cube. Okay, in this case it should be non-perfect fourth power. Okay, so under the radical sign, if you have a non-perfect square or a non-perfect cube or a non-perfect fourth power number, okay, then those numbers are going to be irrational. Okay, now let me make you understand. Let us take square root of 2. Okay, square root of 2. Now square root of 2 has a radical sign, and inside you have a 2, and 2 is a non-perfect square. See, 2 is not a perfect square. The very first perfect square is 1. After that, the perfect square comes is 4. And after that, there is 9. And then there is 16. So these are all perfect square. 1, 4, 9, 16, 25, 36. All these are perfect square. And in between numbers, that is 2, 3, and 5, 6, 7, 8. All these are non-perfect numbers, non-perfect squares. Okay. So under this radical sign, if you put 2, 2 is a non-perfect square. So such a number, by definition, will be irrational. Why? Because somehow if you try to find out the value of this root 2, you will get this type of a number: 1.4142135623731, and it will go on. See that I put there dot 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 dot. It will go on. What this is indicating is root 2 is a number which after the decimal point you are not getting anything which is recurring, so it is non-terminating and non-recurring. And non-terminating, non-recurring number are nothing but irrational number by this definition. A non-terminating and non-recurring fraction is an irrational number, and that is why root 2 is an irrational number, right? Same way root 3. Under the radical sign you have 3. 3 is a non-perfect square. Okay, and if you try to find out the value, maybe by calculator or by some other method, okay, you will get this as the answer: 1.73205080756889, and still it will go on. Okay, so this is indicating that root 3 is a non-terminating, because remainder will never be 0 and the division is not going to stop, and you are not getting anything as recurring after the decimal point. So nothing is getting repeated. Okay, neither a number nor a set of number is getting repeated. So this is coming under the category of, again, non-terminating and non-recurring. So therefore it is a irrational number. See, non-terminating, non-recurring, irrational number. Non-terminating, non-recurring, irrational number. Okay. Same way root 20, it will be 4.47, so it's a irrational number. Is that clear? So this is the meaning of irrational number, and there are certain numbers in mathematics, that is pi value, that is taken as 3.142 dot 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 dot. Okay, this is an irrational number. So if they tell you pi is equal to 3.142 dot 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 dot, and if they tell you pi is equal to 22 upon 7, and if they ask you which of these numbers are rational and irrational, so for this you have to tell that pi is irrational. Okay, because it is telling you that it is non-terminating and non-recurring. And if it is 22 upon 7, then here the pi is rational. So pi can be rational, pi can be irrational, depending on how you are representing that pi number. If you are representing pi in the form of 22 upon 7 fraction, then it is a rational number. If you are representing pi as the actual number 3.142 dot 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 dot, then it is an irrational number. Now I think your doubt, your concept must be very, very clear about rational and irrational numbers. Shall we go to next slide? Okay. So these definitions of rational and irrational numbers, I have the definition and meaning, the concepts I am trying to explain you. Now the third part of this is something called indices. Now what are indices? By definition, indices is any positive integer other than 0 raised to any other integer is a number in indices form. For example, 2 raised to 2, 3 raised to 5, 5 raised to 0. See, these are read in this way, 2 raised to 2. So this 2 is known as the base, and this 2 that is written on the top of this 2, this is known as the power, or it is known as index. Okay, this 2 is known as the base. So any number which is written in the form of a base, and on top of that base you have written some power, okay, then this type of numbers are known as indices, or they are also known as exponents. Okay, so a number of the form 2 raised to 2 is a number in indices form. 3 raised to 5, indices form. 5 raised to 0, indices form. 25 raised to minus 2, indices form. 100 raised to minus 1, indices form. What you have to really check out is this base, the base of this indices number is 2 in this case. Here it is 3, here it is 5, here it is 25, here it is 100. So the index, the base, it can also be positive or negative, okay, but not 0. So it can be integer other than 0, okay. The base can be any number, any integer other than 0, and the power of the index should also be can be any number other than 0, can be any integer other than 0. It can be positive, it can be negative, okay. So an integer which is not equal to 0 raised to another integer which is also a non-zero, this type of numbers are known as exponent number. Is that clear? Or you can say indices number in the indices form, right? An integer raised to an integer, right? So 2 raised to 2, the meaning of this is 2 raised to 2 means you have to take this base 2 and you have to multiply that base the number of times that you have the number shown in the index. So in the index there is written 2 over here. So you have to multiply this base 2 times. So 2 into 2 is 4. So 2 raised to 2 is equal to 4. 3 raised to 5. In 3 raised to 5, this is a number in the index form or indices form or in the exponent form. 3 is the base of the number and 5 is the index or the power. The meaning of this is you have to pick up this 3 and multiply out 5 times, because in the index or in the power you have a 5. So 3 into 3 into 3, that will 5 times you have to multiply. And whatever answer you get by multiplying this 3 5 times, that will be the value of this 3 raised to 5. It works out to 243. 3 into 3 is 9. 9 into 9 is 81. 81 into 3 is 243. Okay. So 243 is a number which can also be written in the form of 3 raised to 5. So this is the way of telling that 243 is expressed in the indices form as 3 raised to 5. See, this is 3 raised to 5. There is a slight difference. Okay, if you write this will be 35. Okay, So 3 raised to 5 will be written as a big 3 and a small 5 at the top of 3. And 35 will be 3 and 5 together. Okay, so don't get confused. So 5 raised to 0. Now anything raised to 0, if base is any number, but if the index is 0, then the value of that indices number or that exponent will be always equal to 1. So take from me any base, okay, to the power 0 is always equal to 1. So whatever is the base, even if it is 5 raised to 0, the answer will be 1. And if it is 3 raised to 0, still the answer will be 1. If it is minus 25 raised to 0, still the answer will be 1. If it is 25 raised to 0, again it will be 1. So whatever is the base, but if the power is 0, then the value of that number will be 1. So anything raised to 0 is equal to 1. So this is another concept. So concept, again I am telling you, the very first concept was 0 upon any integer is equal to 0. Any integer divided by 0 is equal to not defined or meaningless. And third concept is any number, any integer raised to 0 will be equal to 1. Okay, so these are the concepts that you should understand. And in mathematics, these are the things, if you don't understand these things, then in the higher class you will struggle, okay, or you may get confused. So these are the things which are and these things are not requiring any proof at this stage, at least. You don't require, you have to take it for granted and you have to keep in your mind all these things. Anything raised to 0 will be 1. Anything upon 0 will be not defined, and 0 upon anything will be equal to 0. Is that clear? Now let us proceed. Base A raised to an index x can be written as a raised to x. Okay, now this is a number in the index form or the exponent form. Suppose this is equal to y. So you can say that y is a number in the index form a raised to x. Y is a number in the index form a raised to x. For example, 81. 81 is a number, and in the index form 81 can be written as 3 raised to 4. Okay, so 81 is a number. In the index form, 81 is 3 raised to 4. Both are having the same value. 3 raised to 4 is also 81, and 81 can be written as 3 raised to 4. Okay, so these are nothing but two alternate ways of expressing the same value of the number. So 81 number can be expressed in the index form as 3 raised to 4. 9 can be expressed in the index form as 3 raised to 2. Okay, so this is the meaning of indices. So y is equal to a raised to x, and in the index form, this particular integer is known as the base. So a is a positive integer. It can be negative also. It's not always positive. It can be negative also. It's a positive integer, but not 0. Okay. Okay, I've written only positive or negative also. Okay. It's a positive or a negative integer, but not 0. And x is also an integer. X can be any integer. See, the index, this particular thing, the power, it can be 0, it can be negative, it can be positive. So in general, it can be any integer. Okay, you know what are integers? Okay, integers are 0, 1, 2, 3, 4, etc. And then -1, -2, -3, etc. These are integers. Okay. Now integers, though, you must have studied in your 7th grade, right? So this is from integers you are going ahead, and now you are trying to understand what are rational and what are irrational numbers. Okay. Now y is equal to 2 raised to -5. So this is a number which is in a indices form, 2 raised to -5, right? Now 2 raised to -5 can be written as 1 upon 2 raised to 5. Okay, and this can be again written as 1 upon 32 because 2 raised to 5 is 32. So 2 raised to -5 can be valued as 1 upon 32. Okay, so remember there is a rule. If a number is a raised to -x, then this can be written as 1 upon a raised to x. Okay. The same thing I have done here. Okay, 2 raised to -5 I have written as 1 upon 2, and this -5 will become +5. Is that clear? So this is the transformation of a number which can be done in the index form. right? So a raised to minus x is same as 1 upon a raised to x. Okay. For that matter, if it is a raised to minus x, then this can be also written as 1 upon a raised to x. Okay. So a raised to minus x can be written as 1 upon a raised to x. So when you do 1 upon, the minus sign will change to plus. Okay. Here the minus sign is changing to plus. Okay. Okay. And if it is a plus sign, a raised to x, and if you want to write out in the negative form, you can write 1 upon a raised to minus x. This way also you can write. Okay. A raised to x is equal to 1 upon a raised to minus x, and a raised to minus x can be written as 1 upon a raised to x. So remember this, right? So in indices, this is what is something that you should understand. Okay. So I have discussed with you what are rational numbers. I have discussed with you what are irrational numbers. I told you the definition. I have told you the meaning of all these numbers. And now we are going to start with some worked example first. Okay. Now these are some of the worked examples. Okay. And these are connected to this particular topic only. Let us try to work out this work example. Okay, let us understand work example. Now, this is from the book written by Collins. Okay, this is a book written by Collins, and this is referred to by many students in the 8th grade. Okay, so your first example, work example is this one. Write the value of 2 raised to minus 5. Now, this is a number in the indices form, 2 raised to minus 5. Okay. So 2 raised to minus 5, you can always write it as 1 upon 2 raised to 5. Just now I told you. Okay, I told you a raised to minus x can be written as 1 upon a raised to x. Isn't it? So same thing I did here. 2 raised to minus 5 I have written as 1 upon 2 raised to 5. Then this denominator may, whatever you have 2 raised to 5, the meaning of that is 2 you have to multiply 5 times. 2 into 2 into 2 into 2 into 2. This is the meaning of 2 raised to 5. You have to take the base 2 and you have to multiply that base 5 times. Okay, 1, 2, 3, 4 and 5. And the ultimate answer for this is 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So my answer will be 1 upon 32. Is that clear? So 2 raised to minus 5 can be written in this form as 1 upon 2 raised to 5, and it can be also reduced to 1 upon 32. And still 1 upon 32 can be written in a decimal form also. Okay, that for that you will have to either use a calculator or you will have to perform this division, and you will get some answer of 1 upon 32 in the decimal form also. Okay, so it should be something. I'm not going for that. So this is example number 1. Worked example number 1. So what we did in this example, a number was given in the exponential form or the indices form, and we were asked to write the value of this 2 raised to minus 5. So when they ask you write the value, then what you have to do is you have to remove this indices form, the base and the index that you have to remove. So you have to basically work out. So 1 upon 32 is the value of this 2 raised to minus 5. Is that clear? Now worked example 2 is write each expression as a power of 4. So a is 4 square or 4 raised to 2 into 4 raised to minus 3. Now this you have to write, this is an expression, and this you have to write as a power of 4. Okay. So what I'll do, this 4 raised to 2 can be written as 4 into 4 into 4 raised to minus 3. Now 4 raised to minus 3 first I will write as 1 upon 4 raised to 3. Okay, using this rule. Okay, using this rule, 4 raised to minus 3 can be written as 1 upon 4 raised to 3. And 1 upon 4 raised to 3 can be written as 1 upon 4 into 1 upon 4 into 1 upon 4. Is that clear? So altogether you will have 4 into 4 into 1 upon 4 into 1 upon 4 into 1 upon 4. This 4 and this 4 will get cut. This 4 and this 4 will get cut because they are common factors in the numerator and the denominator. And you are left with only this 1 upon 4. So your final answer will be 1 upon 4. Okay. So the expression, this particular a expression is written only in the form of expressed in the power of 4. So can you see 1 upon 4 can be rewritten as 4 raised to minus 1. Okay, 1 upon 4 is nothing but 4 raised to 1. Now this can be written as this entire thing, when you bring it in the top, this will become minus 1. Okay, so this is nothing but, you should know, you should start playing with these things. Okay, this is just a conversion from a raised to minus x equal to 1 upon a raised to x. 1 upon a raised to x is equal to a raised to minus x. You can always do this conversion in the forward direction as well as in the backward direction. Now b part of the question is 4 raised to minus 2 divided by 4 raised to minus 4. So 4 raised to minus 2, first I will write it as 1 upon 4 raised to 2 this way, divided by this 4 raised to minus 4, I can write it as 1 upon 4 raised to 4, right? So first step is I have converted this negative index into positive. Okay, so minus 2 and minus 4 I have converted into 2 and 4. And this is the way you have to do. Now what I'll do, 1 upon 4 raised to 2 I will write as 1 upon 4 into 4. And this division sign I'll convert into multiplication sign, and this 4 raised to 4 will go in the top and 1 will come in the bottom. 4 raised to 4 will become numerator and 1 will become denominator. So 4 raised to 4 can be written as 4 into 4 into 4 into 4 in the numerator. Okay. See, after converting this division into multiplication, the numerator will go into denominator and denominator will come in the numerator. And that is why it is becoming this way. Now again this 4 and this 4 will cut with this 4 and this 4, and you will be left with 4 into 4 in the numerator and 1 in the denominator. So 4 into 4 will be 4 square. Okay, and denominator you have, so no need of writing upon 1, it is just 4 square, and 4 square is 16. Okay, so you have to give the expression in the form of power of 4, so the answer should be this. Okay, no need of writing 16. This is the answer, this is the power of 4. Here this is the answer, power of 4. C is 4 raised to minus 1 whole raised to 3. Now here 4 raised to minus 1 first, what I'll do is I'll write it as 1 upon 4. Okay, this 4 raised to minus 1 I can write as 1 upon 4. Right? And that 4 raised to 1 upon 4 whole raised to 3. So 1 upon 4 I'm going to multiply 3 times. Is that clear? See, this 4 raised to minus 1. Okay. Or you can take it this way, 4 raised to minus 1, this entire thing you are going to multiply 3 times. So 4 raised to minus 1 into 4 raised to minus 1 into 4 raised to minus 1. Then 4 raised to minus 1 I am going to write it as 1 upon 4. This 4 raised to minus 1 I am going to write as 1 upon 4. This 4 raised to minus 1 I am going to write as 1 upon 4. So there will be 3 times 1 upon 4 multiplied. And this will give me the answer as 1 into 1 into 1 is 1 in the numerator, and 4 into 4 into 4 will be 4 4s are 16, 16 4s are 64. Or you can just write 4 raised to 3. Okay. So this 4 raised to 3, if I want to bring in the numerator, I will do that and I will change the sign of this 3. So it will become 4 raised to minus 3. So yeah, ultimate answer will be 4 raised to minus 3. So this was the answer for the C part of the work example. So in this today's video, I have just tried to explain you what are rational numbers, what are irrational numbers, and what are indices, number in the indices form. And certain examples we have started solving. In the next video, we will be doing some more exercise from the same book, Collins' book. Okay, and we'll be doing more and more questions, and we'll make ourselves very, very familiar with this concept of rational, irrational numbers, and the numbers in the indices form. That's all for today, and this was video number 1 for the 8th grade IGCSE students in maths. Right? Bye.